We're going over the Unit 2 review. The test is tomorrow. The review is due at the beginning of class. So again, the key will be posted. Check your answers against the key this tonight, this evening, this afternoon, whenever. And then you can use the videos to go and see the explanations if there's ones you're not sure of, why you got them wrong or how I got the answer. You can go and hear the explanation and see it worked out. All right, so we started with, oh, my pen is being a little funky. Here we go. Just some vocabulary. Okay, so when we were talking about the graphs of sinusoids, okay, those waves, there's the height of the graph, which is the distance from the top to the bottom, the maximum to the minimum. Okay, so it's the total vertical distance, okay, up and down, vertical, okay, between max and min, okay? So that is the height. Now, what does the height help us find that will help us write an equation? The height helps us find the amplitude, okay? The amplitude is what compared to the height? It's half the height, right? It's measured from the midline up to the maximum or down to the minimum, but it's the distance from the midline to the maximum or minimum, okay? So the distance from the midline to the maximum or minimum, okay, it's half the height. Okay, so that's your amplitude. Okay, and then actually, I'm going to try and color code this. So I'm going to redo that real fast, just in a different color. So when people are looking at the key, it's a little more obvious to see. All right, next up, the period of the graph. Okay, so amplitude and height are vertical measurements up and down. Okay, the period is a horizontal measurement. Okay, it's like kind of like the width of the cycle. You could think of it that way. It's the how many radians, because we're going to be doing all of our graphs in radians, is one cycle. Okay, so from one point to a point where it starts repeating itself, how wide is that? How many radians does that take? Okay, so that's the total horizontal distance of one cycle. Now, in parentheses there, it says double the length between a maximum and a minimum. Okay, so if you just think about like a cosine curve, starts high, ends high. What they're saying is if you know the horizontal distance between max and min, you double that. And that's the period. Okay, so it can be from high point to high point, low point to low point. It can be the beginning of a sine cycle would be at a midline, and it would go high, midline, low, back to the midline. That's the period. Okay, however long one cycle is, however wide one cycle is. All right, so your midline is, we said that a second ago, it's where we measure the amplitude from. Okay, it's that equilibrium line that we measure from to the maximum or to the minimum to get the amplitude. Okay, and the midline is going to be wherever your vertical shift takes you. So if there is no vertical shift, the midline is the x-axis, right? The parent functions, the x-axis is the midline. But if there is a vertical shift, is that if there's something added or subtracted outside the function, your graph is shifted up or down, and you sketch the new midline as a dashed line. The frequency, that is how many cycles are completed in 1 unit interval. Okay, so how many cycles are completed in 1 unit interval? That is B. Okay, so we use a lot of that vocabulary describing our graphs and writing our equations. So you need to know what all of that is. All right, in this first section, it says do not graph. You're not graphing these. We're just practicing identifying all the properties, those four main properties. What is the period? What is the amplitude? What is the vertical shift and phase shift? Remember, phase shift means the same thing as horizontal shift. So has this graph been stretched or compressed horizontally, stretched or compressed vertically, okay, shifted up or down, shifted left or right? Okay, that's what we're identifying here. Okay, so as a reminder, put this down a little, I'm going to write the equation. We've written it a few different ways, but so you can have your D at the beginning or the end. And you know what? I'm not even going to put a plus or minus. I'm just going to put D. The D can be positive or negative. So if there's a negative in front of it, that just means your D is negative. Okay, and then you would have plus or minus your A value, and then your trig function, and then your B value, times X minus your horizontal shift. But again, that D could be added or subtracted to the end, as long as it's outside the parentheses. Okay, and then the other thing is the B could be in the parentheses. It could be distributed in. Right now, the B is factored out, okay? But the B could be, I'll write D at the end for this one, actually. So you could have your positive or negative A value, and then your trig function, and then bx plus c in parentheses. So the B is not factored out. So notice this number changes because it is not the horizontal shift anymore. We'll have to do something to it to find the horizontal shift. And then you could have your plus D at the end. Okay, so a couple of different ways you may see your equation. So for part, or number 2, okay, D is added or subtracted on the outside. That's this -5. This -5 is not being multiplied by cosine. It is being subtracted. You could have a -5 at the end over here. Okay, so that is the D value. Okay, your A value is what is multiplied by the trig function. So in this case, 3 times cosine. So 3 is your A value. Okay, your B value is the coefficient in front of X. Whether it's outside the parentheses or inside, the B doesn't change. Okay, so in this case, it's factored out, so that's good. It's the 2. All right, now, because the B is factored out, we know that what we're going to see here is our horizontal shift. So pi halves is going to be our horizontal shift. Okay, so I have a vertical shift of -5. Okay, that's D. And that means it's going to go down, right? You know, I'm going to draw the arrow to help you remember that. That vertical shift, -5, means it's shifting down 5. Okay, the B value, or excuse me, the A value helps me find the amplitude. How do I find the amplitude? It's the absolute value of A. Remember? Okay, so if A is positive, the amplitude is A. But if A is negative, the amplitude is still going to be positive, right? So in this case, it was +3, so it doesn't change. So it is just 3. Now, my B value is 2, which I'm going to use to find my period. Because remember, the period is 2 pi divided by B. I don't know why I just put a 3 there, not a 2. Okay, so period is 2 pi divided by B. So in this case, it's 2 pi divided by 2, and the 2's reduced, so that is pi. So we've got amplitude, we've got period, we've got vertical shift. Now horizontal shift is the opposite sign of what you see in parentheses or inside there. So we see it as negative, so the horizontal shift is positive pi halves, which means it's going to the right pi halves. So if I were to describe this, I would say this graph is shifted down 5, right pi halves, vertically stretched by 3, and it is horizontally compressed by 2. Now you can see the period is half of what it was. The parent function's period is typically 2 pi for a cosine function, and now it's just pi. That 2 horizontally compressed it. So it's half the width, 3 times the height, down 5, right pi halves. Does that make sense? Okay, so let's try 3. 3 is similar, but the B is inside. Okay, so we're still going to start. I'll start with D. Okay, in this case, it's on the end. Okay, it's like having the plus D at the end, but it's outside the parentheses. So I still know anything added or subtracted outside the parentheses is my D value. Okay, my A value is what's multiplied in front of the trig sign. That's a -1. The 1 is not written, it's understood, but that is a -1 for A. -1 times sine. Okay, now my B value is oh, this one's not inside, sorry. It's number 5 and 4 that's inside. Okay, so that B is still outside, so that's good. And then I will be able to see my horizontal shift since the B is factored out already. Okay, so let me go ahead and identify all that. So we said that A was -1, so that means the amplitude is what? Yeah, +1. Okay, the amplitude is absolute value of that. Okay, we said that the vertical shift is 3. So that means this graph is being shifted up 3. Okay, we said that the B value is pi. So the period would be 2 pi divided by pi. This time the pi's reduced, and so my period's just 2. And then my horizontal shift would be the opposite sign of what's in here. So it's going to be -2. So that means this graph is shifting to the left. So this graph is shifted up 3, left 2. It is not vertically stretched, but what does that negative do? A -A does what to the graph? Yeah, what does that negative in front of sine do to this graph? It flips it. It reflects it over the x-axis. Okay, so it's not vertically stretched, but it is reflected. Okay, and then this graph is horizontally compressed by pi. Okay, so it's got a smaller period. So horizontally compressed, reflected over the x, up 3, left 2. Good? All right, let's try 4. Okay, do I have a D value here? What is the D value? So that +4, that 4 is being added outside. Okay, what is my A value? The A value itself is -3. Okay, so that means the amplitude will be +3. Good. And then the B value here is inside, like this. Okay, so the B value is inside, it's the 6. Okay, so that means, I'm going to get a different color here. Move. Purple, I guess. Okay, so instead of seeing the actual horizontal shift, I see the C value. Oh, that purple is really close to that pink. I'll do yellow. Okay, I see the C value here. -pi is the C value. Okay, so let's look at how we're going to use that. Okay, so D is our vertical shift. So we know our vertical shift is +4, which means the graph is going up 4. Okay, you told me A was -3, which means the amplitude is +3. Okay, now B is the 6, which means the period is 2 pi divided by 6. 2/6 reduces to 1/3. So just pi thirds is our period. All right, and then last but not least, the horizontal shift. If the B is not factored out, remember your horizontal shift is -c divided by the absolute value of B. So here, the negative, and then the C is -pi, divided by the absolute value of B. The absolute value of 6 is 6. So negative, negative, that's going to come out. What's going to happen with the double negatives? Yeah, it's going to be positive, and then pi 6. So the horizontal shift is positive pi 6. Sometimes you'll get the hang of this, and you won't even have to write all that out. You'll just look at this. You'll say, okay, it's the opposite sign of C over B. So positive pi over 6. Okay, that means this graph is shifting to the right, pi 6. So this one is shifted right pi 6, up 4. It's reflected because of the negative A. It's stretched vertically by 3, and it's compressed horizontally by 6. Y'all good with that? All right, one more. All right, D is what? What's the D here? Is it 7? No. The plus 10, that's what's being added to the outside of the function. What is that? 7. That's the A value. That's what's being multiplied by the trig function. Okay, what is B? B is the 3, good. So is 2 pi the horizontal shift, or is that the C value? That's the C value. It's not the horizontal shift because the B is inside. Okay, so we said the A is 7, which means our amplitude will be 7. Okay, so vertically stretched by 7. Okay, the B value is 3, which means the period will be 2 pi over 3, which that doesn't reduce, so 2 pi thirds is my period. And then I'll go ahead and do the vertical shift is 10, so that means it's going up 10. And last but not least, the horizontal shift. It is the opposite sign, so it's going to be negative, and it's C divided by B, so 2 pi over 3. Yep. And that means the fact that it came out negative means this is shifted left. So left 2 pi thirds. All right. Y'all feel okay about those? Good. Yeah. Any questions about those? No, you don't get to use the review on the test. No. But it is a quiz grade. All reviews are quiz grades. So it's like a double daily grade. Exactly. All right. Now these three, I guess they're not all three the same, but 6 and 7 are similar. They want us to write the equation given the attributes. So the last ones, we were given the equation, we wrote the attributes. Now we're given the attributes, we write the equation. Okay, so we're using the same information, we're just working in reverse here. Okay, so they tell me, what colors did I use? I'll try and keep my color coding the same. So I used green for vertical shift, pink for amplitude, blue and orange. Okay. So this one tells me my amplitude is 2. My midline is at y equals 3. That's going to help me figure out my vertical shift. My period is 6 pi. That's going to help me figure out my b value. And then my phase shift or horizontal shift is pi thirds. Yeah. All right, so let's think through this. The midline, that's that dashed horizontal line we would draw. That's at that equilibrium line, the center of the graph. That tells you your vertical shift. Okay, so the midline being at 3 tells me that my vertical shift is up 3, which tells me my d value is 3, positive 3. Does that make sense? Okay, the amplitude being 2 tells me that my a value is 2. Okay, it's not going to be negative because they would have to tell us that there was a reflection if it was negative. A. Does that make sense? Okay, now the period being 6 pi, remember we were saying b equals, or the period equals 2 pi divided by b. Okay, you can switch the b and the period and say, well, b equals 2 pi divided by period. Because if you wanted to isolate the other, they end up just switching spots when you multiply the one over and then divide the other. Okay, so we can do it this way as well to work backward and find b. So 2 pi divided by 6 pi, the pi's reduce. 2 over 6 reduces to 1/3. So we've got A, B, and D. So the last thing we need is C, which we actually don't have to write the equation with the C. We can go ahead and leave it as the horizontal shift and just write our B factored out. That's going to be the easiest way for us to do it. So I'm going to write this. Do y'all prefer to have the D at the beginning or the end? Okay, we can do one of the examples with it at the end and one with it at the beginning. It doesn't matter. So we'll start with the amplitude of 2. Okay, and they said to write this as a cosine function. So COS. Okay, my B value is 1/3. And I'm writing it with it factored out. So then I have X minus my horizontal shift. My horizontal shift is pi thirds. And then my D value is a positive 3, so plus 3 outside the parentheses. Now, the phase shift was positive, so it should be a negative in the equation. Remember, inside those parentheses, it should be the opposite sign. Now, if you wanted to write it with the B factored in, or if this was multiple choice and you didn't see this, all of the choices had the B inside the parentheses. Okay, you would just distribute the B in and see what you get. So if I wanted to do that, I could also write this as 2 cosine, and then it would be 1/3 X. Now 1/3 X would probably be written how? Instead of writing it as 1/3 times X, it would probably be written as X over 3. That's the same thing as 1/3 X, right? If it was free response, yes. But if it was multiple choice, you just need to know that means the same thing as 1/3 X. Okay, and then if I distributed the 1/3, that's still negative. So 1/3 times pi thirds, you multiply fractions, you multiply the numerators, so that would just be pi, and you multiply the denominators, so that would be 9. And you'd still have your plus 3 on the outside, either here at the end or at the beginning. So both of those are correct. If it was multiple choice, you would just have to see, do they have the B distributed in or the B factored out? So far, so good? Okay. 7. Write the equation of a negative sine function with an amplitude of 9, a period of pi, a phase shift of negative pi halves, and a vertical shift of negative 5. Yes. So we know D is negative 5 because the vertical shift is down 5. We know that the amplitude is 9, but they say to write this as a negative sine function. So that tells me my A needs to be negative 9. Does that make sense? Because of that negative there. And then the period is pi. So B is 2 pi divided by pi. So those pi's reduce and it's just 2. And then my phase shift, that's like my horizontal shift, is negative. So that means in the equation, what am I going to write? It's going to be plus. Good. Okay, so I'm going to write the D at the beginning of this one. So if I start with negative 5, and then I would have minus 9 sine, because they said to write it as a negative sine function. And then my B is 2x minus my horizontal shift. But again, we said it's negative, so minus the negative, that's going to be plus pi halves. Okay, so that's one way to write it. If you wanted to distribute the B in, you could. And you could write it as negative 5 minus 9 sine. Then that would be 2x. And then again, 2 pi over 2. So the 2's would just reduce. So it would just be plus pi. So both of those ways are correct. And again, it could start with just the negative 9 sine, and then that minus 5 could be at the end outside the parentheses. All right. 8 is a little different. Instead of just listing out those 4 things, they tell us the maximum and minimum value, or they're asking us for the maximum and minimum values. Okay, so let's think about this. If I want the maximum and minimum, I definitely need to know where the midline is, right? Where's the middle of the graph? Okay, and that's determined by D, which here is good. So 5.8 is the midline. If it helps you to sketch a picture, sketch a picture. So they're saying that this graph is going to be shifted up. That midline is going to be at 5.8. Okay, and then they tell you your amplitude is 0.4. Okay, so that means your high point and your low point. Okay, let's say this one is cosine, and I'm not drawing it very good. I'm not going to put those points there because this is shifted right to. So my high point would actually be over. It ends up looking something like this. If you were to graph it, they're not asking you to graph it. I'm just trying to help give you a visual of what's happening here. Okay. So what they're saying is that midline is at 5.8 because that's your vertical shift. Okay. And then your A value is 0.4. So your amplitude is 0.4. So from the midline up to the high or from the midline down to the low is a distance of 0.4. So you're having to do 5.8 plus 0.4 to get to the high. What's 5.8 plus 0.4? Good. Okay, so this is at 6.2. And then to get to my low point, I start at the midline and I subtract the amplitude. So what's 5.8 minus 0.4? So those are my maximums and minimums. So you did not have to draw a picture. You could just add and subtract the amplitude from the midline, from the D. So it's D plus A and D minus A. Good with that? All right, good. All right, now let's look at some graphs and try to write the equations. And they said to do all of these in radians. Okay, so, and they tell you what cycle to look for. So sine. Okay, so I'm going to look for a sine cycle. So sine is midline going up is the starting point, right? That's the shape of a sine cycle. If you need to sketch it, remember sine starts in the middle, goes up, down to the low, back to the middle. That's a sine shape. So that's the shape I'm looking for. And I see one right here. That's a sine cycle, isn't it? Starts at the midline, goes up, down to the low, back to the midline. I could also look at this sine cycle. That's another sine cycle. So you actually have a couple of correct starting points here. If there is one that's at the y-axis, starting at the y-axis, I'm just going to use that because then I have no horizontal shift, right? Makes writing my equation a little easier. Okay, so if I do this as my starting point, what color was I using? I think it's orange for horizontal shift. If I use this as my starting point, that means that I have no horizontal shift. I'm starting at the y-axis. Now, is there a midline? Has my graph been shifted up or down any? Shifted, not stretched, up or down, shifted. Like, is the midline the x-axis or has the midline moved up or down? The midline is the x-axis here, right? Okay, so my midline is the x-axis. It has not moved, so I'm going to label that as no vertical shift. So no horizontal shift, no vertical shift, but what somebody, hang on, I'm going to check my colors I'm using here. Oh, I did pink for amplitude. Vertical shift, I did green. Change that real fast to green. Okay, so the amplitude is measuring from the high point to the midline or a low point to the midline. It doesn't matter. Okay, that's the amplitude. Okay, and what is our amplitude? If our midline is at 0 and our high is at 2, the amplitude is 2. Okay, what are we missing? Period. Okay, you can measure that for the cycle that we highlighted there. So from beginning to end of that cycle, that is at pi. So the period is pi, which means my b value will be 2 pi divided by the period, which is pi. So the pi's are going to reduce and b is 2. So I've got an amplitude of 2, which means a is 2, a b of 2, no vertical or horizontal shift. Okay, so I'll start with 2 sine of 2. Now you could do, because there's no horizontal shift, it doesn't matter if that 2 for the b value is in or outside the parentheses, because there is no horizontal or vertical shift. So that's it. Nothing added or subtracted inside or outside. Good? All right. Let's try another. Okay, here I'm looking for a cosine cycle, but I definitely know this graph has been shifted down because the midline is not the x-axis anymore, right? So that's the first thing I'm going to do is draw, okay, here's the midline. So that means that I have a vertical shift down, and that's at -3. So a vertical shift down 3. That means D is -3. Okay, bless you. So the amplitude here, that low point's at -4. What's the distance from -3 to -4? 1. So the amplitude is 1. Now I'm writing this as a cosine cycle. Cosine goes high to high. That's a high point on the y-axis. So I'm going to use this. You could use this one over here, but then you're having a horizontal shift. So if I use the one that I highlighted, I have no horizontal shift because my starting point is on the y-axis. So I've got vertical shift, horizontal shift, amplitude. So now I just need period. Now this one, look at how the x-axis is labeled. There's no pi's in it, are there? But it says everything's in radians from the instructions. So those of you who did this, you may have thought this high point is at 6. How many of y'all thought that? It is very close to 6. But if you look, that high point is a little to the right of 6. You'll see it. So if you did it using 6 as that point, what that would look like is your period is 6. And so your B value would be 2 pi divided by 6, which would be pi thirds. Okay, so I'm not going to need you, if this is what you use, you don't need to redo it. There's not going to be one on the test where this the x-axis is scaled like this without the pi's. But this is actually, that high point is actually at 6.28, which is what? What is pi? So 6.28 is 2 pi. This high point is actually at 2 pi. But I don't expect you to say, oh, that's just off 6. Oh, that's supposed to be 2 pi. So don't worry about it. I'm not going to put one on the test where it's like that. So if you thought, oh, that's at 6 and you used 6, that's okay for your review. Okay. But technically, it's actually a high at 2 pi. So technically, my period is 2 pi, which means my B value would be what? What's 2 pi divided by 2 pi? 1. Okay, so if you wrote your equation as -3 plus cosine of pi thirds x, that's okay. But really what it was supposed to be was -3 plus cosine of x. There was supposed to be an understood 1 as the B value. But if you didn't catch that, it's not a huge deal, and that's how you would have written it. Does that make sense? Okay. I believe there are 2 other of the graphs that have the x-axis scaled this way. It's in radians, but they didn't put the, instead of putting like pi and 2 pi and stuff, they just labeled it 1, 2, 3, 4, 5, 6. So like just past 3 is 3.14. This is supposed to be at pi. And just past 6 a little bit, that's 2 pi. Okay, I think there's 2 others on the review that way. But so what we didn't get to in this class today, remember you can check the other videos. So I'm going to stop this recording here and I'll start another recording with number 11.